All right, one more time. Here's how it works with any time you can get your forces to be a 3-force system. Usually that means when you've got one pin joint and one roller joint, and any other number of forces, this can occur. This even includes trusses if you get it down to the point where you solve and only have two unknown internal reactions. Let's see if this will record. Animations and slideshow and from beginning. Let's see how that works. All right. So any set of forces, you just need to slide two together, two more, two more. This should go relatively quickly, though of course you know how to do this now. Lots of other ways as well. You know how to solve for the reactions by writing a matrix here, writing a matrix here, writing a matrix here, writing a matrix here, having an asterisk on this one and this one, calculating the torque about the initial point for this force and this force, calculating the reverse torque for that, solving for the reaction, taking away the asterisk, doing the same over here. But you should also still not be able to do this. So we start with that depiction. You have your two forces. You slide them so their tails are at the point of concurrency. You add them together tip to tail by sliding one. You're left with a resultant. You get rid of the original ones, and all you're left with now is a 3-force system. That 3-force system has a point of concurrency which was solved algebraically by taking the intersection of two lines. That becomes your point of concurrency. You also have a slope, which could have been solved by adding the sum of the forces in the y, rise over run, over the sum of the forces in the x. When you have a point and a slope, you have a point-slope form of an equation. You also know a vertical line, or especially if you run out of paper, you can solve this equation for when the x is the same as your support on the right. That will get you your point of concurrency. You have your original point, therefore you have your second point of force. And so you can do all kinds of sliding or summing or adding or whatever. Just remember there's more than one way to do vectors. And in engineering you should feel confident of doing more than one, especially these quick graphical solutions which are elegant and tie you to the history of the profession as well as the future of the profession as we check all these computer solutions that are many times going to be correct, but on the odd time out will be incorrect due to improper input of a plus or a minus. These vector solutions with sliding and using, as long as you keep your vector heads in the right direction, do not tend to give you an answer in the wrong sense. Thanks for listening.